Let us recall certain learnings we had on day number 1. In day number 1, we made attempts to understand what is lean and what is Six Sigma. Am I correct? So lean is all about identification and reduction of waste. If possible, we even eliminate waste. Hope all of you are with me on this, right? You all very well know what is a waste. Anything that is not adding value, anything that cannot drive satisfaction, anything that drive dissatisfaction. Note my words. Anything that cannot drive satisfaction, that is also waste. Anything that drive dissatisfaction, that is also waste, right? And ultimately, all of them are inefficiencies. Reducing and eliminating the inefficiencies is known as lean. Similarly, reducing and eliminating the defects, non-conformances by applying the principle of reducing the variation is known as Six Sigma. If you reduce the variation and reduce the defects, your effectiveness will keep improving, right? So fundamentally, the defects are nothing but forms of ineffectiveness. So the approach of enhancing or improving our effectiveness through reduction of variation is known as is known as Six Sigma. The lean and Six Sigma, whatever principle lean and Six Sigma gives, that goes very well with the IATF standards. That is why sometimes we used to say applying lean Six Sigma can help you in compliances also. If you are into automotive industry and if you need to stick to the standards of IATF, then simply practicing the lean and Six Sigma principles can take you close to the standards, right? So so lean is understood, Six Sigma is understood. We also understood operational excellence. What is operational excellence? In terms of effectiveness as well as in terms of efficiency, we should be better than our competitors. We should be better than our competitors. That means we can now proudly say we are operationally excellent. Once you reach this state, nobody can stop you from growing. Your organization has to grow, right? All that can what do you call happen is maybe some slowing down can happen. You just have to ensure the momentum is never lost and everybody is aligned, synergized, and hence your organization can grow very fast. And that's why operational excellence is very, very important, and which can definitely lead to uh, maximizing your market share as well as your profits. And of course, it will be an inclusive growth. Everyone will feel the winning if you are operationally excellent. We understood operational excellence. And then we talked about problem solving methodologies. There are several methodologies, out of which the superior one is the Dmaic methodology. If you create a pyramid of all problem solving methodology, then Dmaic will appear on top of the pyramid, right? Dmaic will appear on top of the pyramid, which means if you master the Dmaic, you are master of almost all other problem solving methodologies. It can be your 8D, or it can be your A3, or it can be your PDCA or PDSA, or it can be your any approach, right? Ultimately, all of them are nothing but the certain steps you are learning here in the Dmaic methodology. There are 15 steps you are trying to master here. So all these 15 steps, the modification of which can lead to the other methodologies. So one method which can help you solve all kind of problem is the Dmaic methodology. And we understood in defined phase, the efforts goes in the direction of understanding a problem. A problem is considered to be understood only when it is stated in specific terms. You can't have a broader state problem statement and then solve it. It is not possible. It is like boiling a big ocean. You will never be able to boil the ocean. However efforts, amount of efforts you put in, you will never be able to boil it. Oh, but if you are really interested in boiling water, you must take a pot full of water and then boil it separately. Now, no, the scope is clear, minimal, and with available resources, you will be able to achieve your result. Same manner, when you are solving a problem, first make sure you define the problem in specific statement. The problem should be to talk about a specific requirement. And using the word quality is like, referring to a ocean. And ocean is so big. So similar, meaning applies to the word quality also. You can't simply say you are solving a quality problem. What is exactly going wrong? What is the customer requirement? What is that metric you need to actually improve so that the customer requirement can be met? We call it CTQ or CTB or whatever it is. Nothing but the feature in your product. Nothing but the feature in your service. It can be anything, right? For example, in our training program, the number of tools you learn by completing the program, and that is a good metric that can talk about the quality of, the session you are going through or quality of the training you are going through. It is one such metric, and it is not, the only metric. There are several metric that, become the complete specification or the CTQ metrics in your product. So which metric is under trouble? That must be understood. What is the target? That should be understood. Where is the metric right now? So that how much is the deviation? If you speak in this language, you have understood the problem, the defined phase is over. If you are not able to use this language, you are very generic in, talking about a problem. That simply means you have still not understood the problem. The defined phase is still on, and keeping the defined phase on, moving to the measure phase or jumping to the analyze phase. Somebody can even jump to the solution phase. That is going to make the problem occur, repeat, no, again and again. The problem will continue to reoccur if you jump the phases. So what is our goal in defined phase? Thorough understanding of the problem. The problem is made measurable, and that measurability is communicated to all the team members. Everybody come to the same line of understanding. And with respect to the metric, customer requirement is also well defined. Customers, tolerable limits are understood. Target, upper spec and lower spec are understood. A unit of measurement exists. A formula exists. If you say rejection rate, yes, there has to be a formula to calculate the rejection rate. If we say the hardness of the material, there has to be a formula to measure the hardness of the material, and there should be an instrument to measure the hardness of the material, right? This is known as the define phase. Then you formulate the team and create a project charter. You write your business case, problem statement, goal statement, and I think we have taught you how to make use of, or make use of the AI tools to create even a complete project charter for us. Hope all of you are aware of it, right? If I simply ask you to develop a project charter in 5 minutes, you should be able to develop a project charter. But provided you give the proper prompt, you have to communicate what is the metric you want to improve, all that, right? So this is exactly the define phase. There are several tools that can help you in define phase, like CTQ tree, Pareto plot, or sometimes the control chart can also help you. You understand, what happened over the last 30 days. Sometimes we call it, the time series analysis over time. What is happening? 30 days, 60 days, or whether the rejections are repeatedly occurring at a stable manner, or is there an increasing trend or a decreasing trend. So you need to understand what is going on with your process, and then try to define a problem, and then get the project charter approved. Then you are required to move on to the measure phase. When you move on to the measure phase, there are two things that will happen. First thing is whether the existence of the problem should be validated. In define phase, you can be exempted from, even using data. Even without data, with the informations available, you can actually you can complete the define phase. In many projects, define and measure will go on in parallel. That means data collection will also happen. Problem understanding will also be happening parallelly. You can also do it that way, so that so that while submitting your project charter itself, you will have all the data. But you should also be conscious enough that the data is clean, means data should be error free. The data should be credible. It should be a real representative of the situation. Your data should be able to represent the realistic situation. Otherwise, you might understand something and what is actually happening can be something else. That should not be the case. So in measure phase, our idea is we are going to validate the problem. Yes, a problem really exists. A problem should really exist, right? People are telling and data is also confirming. This is known as validation. So problem existence is confirmed. And also you need to now think about collecting sufficient amount of data so that the current state of the metric, which is under improvement, is calculated accurately. If your blood sugar level, if you just check your blood sugar level for 1 day, you might come to a conclusion. If you check your blood sugar level for 1 week, you might come to another conclusion. If you check your sugar level for 30 days, you might come to some other conclusion. If you check your sugar level continuously for 1 year and then look at the average, you might come to, completely different conclusion. So you need to make the right choice. How much amount of data will be the right one, right? Normally, thumb rule, we can say it's 30 days, but the idea should be your process should be stable over the data collected period, whatever period you collect, right? So the out of the what do you call over a period of time, the recent period should be considered, and in that recent period, your control chart should demonstrate stability. If your control chart could demonstrate stability for the last 10 days, then you take only those 10 days and try to define your problem. If your control chart could demonstrate stability for 30 days, then probably you can, whether you take 30 days data or 15 days data or 1 week data, all of them are going to give the same meaning. Hope all of you get my point, isn't it? So the period of data collection to validate a problem depends on your ability to actually read the data. Probably you plot it in a control chart and ensure there are no out of control scenarios. There are no out of control. See, out of control scenario is different from a situation of incapability. Even if you do not meet your customer's requirement, still your process can be in statistical control. Instead of saying out of control, we must say our process must be in statistical control, right? Statistically in control may not mean your process meets the customer requirement. Statistical control need not mean your process is defect free. That's why we do capability analysis, isn't it? And so you can use control chart and to judge on the data collection period and then understand the baseline, then redraft your problem statement. Redraft your problem statement. And in order to redraft the problem statement, you must measure the baseline. If you are attacking a problem with respect to hardness of a material, then now you recalculate the hardness with the chosen period of data. Or if you are talking in terms of first pass yield, calculate the first pass yield for the last 15 days or 10 days, whatever you decide after going through the control chart. That should be the baseline. Or you are talking in terms of CP and CPK, calculate CP, CPK now. And modify your problem statement. Or you are talking in terms of turnaround time, you are talking in terms of attrition rate, or you are talking in terms of accuracy percentage, whatever is your metric. You have a formula to measure it. You have a data also. Use the data, use the formula, and then recalculate. That will become your baseline. This is also known as the current state of the pain metric. Once the baseline is clear, measure phase is over. Once the baseline is clear, measure phase is over. So define phase, we defined the problem. In measure phase, we measured the baseline, nothing but the current state of the problem. Then in the analyze phase, we actually analyze to identify the root causes. Now here, you must have a good command over using the tool y equal to f of x. Very, very simple tool. But then many a time, people don't use it properly. right? Y refers to the output variable. X refers to the input variable. What goes into my process, what comes out of my process, and what am I doing in between? This knowledge is very important. Yes or no? What goes inside my process? See, I'm talking about your process, not my process. I'm only saying my, but actually it refers to you because your product can be different, your service can be different, your domain can be different. But you should, in any case, you should know what are you doing, what am I doing, and what are the inputs I'm using, and what is the output I'm producing. And you should be able to measure all of the three. You should be able to measure all of the three. Your output also you should be able to measure. You can't say, sir, I produced a coffee, but I can't measure, anything in my coffee. It's a cup of coffee. That's all. Then you are not fit to work in Six Sigma projects. Coffee is good coffee, sir. All that I know is coffee is good or bad. Then you are not fit to work on a data-driven project. It can be a coffee, but the quality can still be defined using certain metrics. You measure something from your coffee. You measure something. You measure the temperature and write it down. Possible. You measure the strongness of the coffee and write it down. You measure the sweetness and write it down. Maybe certain things. Okay, let's say no, the aroma of the coffee. No, sir, I don't have anything. I can only smell or I can only take survey. Okay, one or two things. Okay, but everything. If you are saying no, sir, I can't measure anything, then you can only provide approximate solution. You will never provide accurate solution. Hope all of you are with me on this. This knowing your input and knowing your output and knowing what are you actually doing with your input, step by step process, isn't it? Your process is nothing but set of step by step activities in a particular sequence. You can't change the sequence also. You have an SOP, a standardized. All of us are solving problems with respect to a standardized process, not for a process, where standard doesn't exist. If standard doesn't exist, statistical control will not happen, right? So step by step activities, and that's why we are developing the SIPOC diagram in the defined phase. Now the understanding on y equal to f of x is very very important. One side is your y, single y variable. The other side is several x, multiple x. And you should be able to write the x in such a way that the root cause must be must be inside the list of x factor you are writing. Are you with me on this? Otherwise, there is no point of you saying, sir, I am 10 years experienced in the field. There is no use. You should be able to list all the x. If you don't want to write all the x, okay, write a part of it. But within the part of it, the root cost must be included. Otherwise, you have to write all the x. If there are 145 x factor, you have to write all 145. No, sir, I don't have that much time. Then write only 20. But inside the 20, the root cause should be present. Otherwise, you can't simplify the task. Your fishbone diagram should be a complex diagram showing all 145 x factor. Are you with me on this?
Yes, sir.
Yeah, the fishbone diagram should show all x factor. No, no, no. I want to cut short. No, I want to be very smart. Okay, you can be smart. Remove as many factors as you want, but you are not allowed to remove the root causes when you are doing that simplification, right? And somehow, if you narrow down 145 root causes into just 20 root causes or 20 x factors, now you can literally test each one of it. Possible, isn't it? Testing 20 factor is possible. You might spend some time, 20 days or 30 days. All that you need is the value of the particular x factor which you are suspecting, some data about the x factor which you are suspecting. While collecting the data about the x, you should also collect the data about the y. Very simple. Are you with me on this? I suspect on a particular x factor, let us say x4. One fine day, I record the values of x4 from morning till evening. Why am I recording the value of my X factor from morning till evening? Because that's the time something goes wrong and some problem is happening. I understood. In defined ways, we have understood everything, isn't it? So every shift it happens. So start of the shift till end of the shift. Every half an hour, the X factor is recorded. at the same half an hour, the y variable should also be recorded. Do you understand? X is recorded every half an hour, and y is also recorded every half an hour. And you very well know your x can exist in a particular range. Your x can exist in a particular range. Am I right? This is known as the range of investigation. The range of investigation should always be the operating range. The range of investigation should always be the operating range. It can be the tool angle, right? Tool angle always, changes between, always, varies from 10 degree to 12 degree. What is the operating range? Just 2 degree only. So throughout the day, you have certain readings pointing 10 degree. You have certain readings pointing 10.5 degree. You have certain readings pointing 11 degree. Certain readings 11.5, certain reading 12 degree. Are you with me on this? 10, 10.5, 11, 11.5, 12. Now how many possibilities for your x? 5. These are known as the level of the factor. Your factor exists in 5 levels. 5 values are possible. Out of the 5, definitely one is going to optimize your y. Out of the 5, at one particular level, your y is going to be meeting the customer requirement. That is why you are operating in 10 to 12. Yes or no? Somebody know the design while designing the process, they have included, yes, the operating range of the cutting tool angle should be 10 to 12. But now when I check, there are 5 possibilities happens within 10 to 12. Sometimes my tool is 10 degree, sometimes it is 10.5. Okay, so now out of the 5 values, to definitely at or around one of the value, my y is going to be in a highly acceptable situation. Y is going to be optimized. What is the best out of 5? That is your question now, yes or no? What is the best out of 5? We already studied one tool, hypothesis testing tool. Whenever your x exists in 2 or more levels, what is the hypothesis test you must do? Tell me, what is the hypothesis test you must do? If your x exists at 2 or more levels, that means
It
you
is
are
a very,
comparing. Ah,
it is
yes.
a variable test, sir. ANOVA.
Very
ANOVA, sir.
good. Excellent. Excellent. When your data is divided into 2 or more number of groups, all readings closer to 10, one set of reading. All reading closer to 10.5, another set of reading. Isn't it? So I somehow divide my X into 5 categories, and so my Y is available for all categories. Now this matches the scenario of ANOVA. Now you perform ANOVA and look for the p-value. If the p-value goes below 5%, your suspect is correct. If your p-value goes below 5%, your suspect is correct. You can modify the procedure now. You realize 10.5 is the best reading, not 10 to 12. 10.5 is the best reading. If your reading goes closer to 10, there is a problem. Product becomes unacceptable. If your reading goes closer to 11 and above, then also there is a problem. Now you are going to redesign the process. 10.5 plus or minus zero point 0.2 is the revised operating range. How many of you understand this? 10.5 plus or minus zero point 0.2 is the revised operating range. Call your team, conduct a meeting, and check for the possibility. Can we maintain the cutting tool angle in this very smaller operating range? Earlier, it was very flexible, 10 to 12. But now it is 10.5 plus or minus zero point 0.2. If all of them says, yes, sir, we can certainly maintain that, there are possibilities. That means that becomes your solution to the problem, one of the solution. Are you with me on this? Are you with me on this? Very important, right? Because here it's a decision is data driven. But certain factors, you can validate very easily. Those I very well know you are very much capable of making those decisions. But when it comes to data, this is the logic you need to follow, and that's where the p-value comes into picture. In my example just now I discussed, my x variable is measurable. Cutting tool angle is measurable. By Y variable, let us say the hardness of the material or hardness of the material or strength of the material. That is also measurable. Surface finish, that is also measurable. X also measurable, Y also measurable. You can start with scatter diagram. You can start with scatter diagram. You can finally take it to ANOVA. You can finally take it to ANOVA and confirm the factor is the root cause. Then finally, then in this manner, you have to validate the root causes one by one. You have to validate the root causes one by one. Let us say now you have, in this manner, you have validated 3 root causes out of the 20. You have validated how many? 3 root causes out of the 20. That means what? All remaining 17 factors are already optimized. Am I right? There is no doubt. They're all, in favor of you. Like you have, 20 friends. Except 3 friends, all remaining 17 friends are real friends. There are no problem with them. Possible, yes or no? If they are real friends, they always tend to help you. The effect is always positive, yes or no? Not only that, the effect is always constant. Do you understand? If I am your best friend, I will always be supportive to you. My effect is well predicted. It is always a constant. Are you with me? That means though I have a tendency to fluctuate my mindset, but when the matter is related to you, my mindset will not fluctuate. I will simply stay positive. Do you understand? I have a tendency to act as a variable, but I don't act as a variable with you because you are my friend. So I behave like a constant. Are you with me? If there are 20, even though there are 20 X factors, 17 of them are made to act as constants. You don't have to suspect those factors. You are given little flexibility for your friend. You are given little room for variation. But that variation is not going to affect your Y. Leave it. In, in addition to the 17 factors, what is the total number of factors? 145, isn't it? Out of 145, now 3 are culprits, 17 are innocent. How about remaining 125? They are also innocent, isn't it? The 120 plus 17, 120 plus, 125 plus 17, 142 factors are constant. This effect, this constant effect will appear as a constant term in your regression equation. This constant effect, because this will always happen. If you open your supermarket, always a sale of 2 lakhs will happen. Do you understand? Of course, the 2 lakh depends on 142 factors. But every day your sale is minimum 2 lakhs. Can you see that? But 3 factors are most important. If you manage those 3 factors, your sale has the capacity to touch 5 lakhs per day. Are you with me? So right now, only 3 factors are critical. Availability of the stock, right? And then your salesperson. And then probably the third factor, offers. These 3 are the critical factors. Because of these 3 factors only, the sale drops from 5 lakhs to 2 lakhs. Are you with me on this? Now you take care of these 3 factors, your sale will try to stabilize around 5 lakh, which is very good for your supermarket. Yes or no? So the constant term I have told you, constant term will appear in your regression equation. Where from the constant term comes, I told you. Now there are 3 factors are root causes. If I announce offers properly, I get extra 1 lakh sale. I get extra 1 lakh sale. My 2 lakh has now become what? 3 lakhs. If I keep the stock availability properly, all fast moving items, I frequently, load it. I never run out of stock. So I get another 1 lakh sales. Now, what is my revised sale now? 4 lakh. Now my sales team is also made available. They are trained enough. So they handle the customers properly. So I get another extra 1 lakh sale. Now, what is my total sale now? 5 lakhs. Isn't it? These three were root causes. If I mishandle them, 5 lakh can drop to 2 lakh, or can drop to 3.5 lakh, or can drop to 4 lakh, or can drop to 2.25 lakh, and all these things can happen. But somehow I am controlling these three factors. So what happens? My sale stays around 5 lakh. So, but right now these three factors, there is a variability possible. Either I should be able to control on a daily basis, or I should find a way to convert them into a constant. Can you make certain offers available on for all the 30 days in a month? Now the offer factor is converted into a constant. Yes or no? That is why nowadays wherever you go, every day they give a name and then they give you the same offer. On Pongal also you get the offer. On Diwali also you get the offer. Even non-festival days also you get the offer. They call it Black Friday offer. Isn't it? So somehow the attempt is we want to convert all the variables into constants and then derive a constant effect on our y, and that should be a positive effect. So suppose assuming each factor gives 1 lakh extra sale. Now can I say all the factors have equal effect on my y? All the three root causes have equal effect on my y. Yes or no? 1 lakh each. 1 lakh from offer, 1 lakh from stock, 1 lakh from salesperson, and 2 lakh constant effect. When I add all of these things, it comes to 5 lakhs. My 5 lakh, how it comes, I am able to understand. My 5 lakh, how my supermarket is producing 5 lakh every day, I am able to understand. Now you have a good process knowledge, yes or no? If I further ask you, what are the other factors? That also you will be able to write a list. Yes or no? When I ask you what are the three root causes, you will tell me x1, x2, x3. What are the other factors? X4, X5, and then up to X145 you are telling. All right. But now in this condition, if you frame a regression equation in this condition, if you frame a regression equation, your regression equation will only have three variables. How many variables? Only three. X1, X2, X3. What is X1? Offer. What is X2? Availability of the stock. What is X3? My salesperson. Only three factors. Only three factors will appear in your regression equation plus one constant. Am I right? And for each factor, x1, x2, x3, there will be a number attached to it. There will be a number attached to it. If that number is positive, you get extra sales. If that number is negative, you will get sales going down. Do you understand? For y equal to x1, x1 plus x2 plus x3 plus constant. And along with the x1, there will be a number. Let's say 2x1, 3x2, 4x3. But in our case, we found that the effect is same. 1 lakh extra sales from each factor. That means the coefficients are going to be same. It can be any number. 2x1 plus 2x2 plus 2x3. Are you with me? All the three numbers are same. That means all the three factors are going to give you the same effect. Got it? And if the number is positive, the effect is going to be positive effect. If the number is negative, the effect is going to be negative effect. This is known as regression coefficient. Y equal to 2x1 plus 2x2 plus 2x3 plus some constant. Let us say, we said constant 2 lakh sales. Okay. So I will write like this. Y equal to 1x1 plus 1x2 plus 1x3 plus 2. Because my number refers to lakhs sale. 2 refers to 2 lakh sale. Now x1, x2, x3 has a coefficient. And if I set my x properly, it will give the extra sale of 1 lakh, and all the three are giving same effect. And so my total sale will be 5 lakhs. I will ensure my x1, x2, x3 are maintained at this level throughout the 30-day period in a month, so that every day in a month I get 5 lakh sale. My solution is achieved, isn't it? My job as a sales manager is, statistically we are talking, but practically, yes, you need to take the right action. What kind of offers and all that you can do, that is your process knowledge. So ultimately, if you frame a proper regression equation, you and then evaluate the quality of the regression equation. You can evaluate the quality of the regression equation using the tool R square. The R square can now become closer to 100%. If you have done your fishbone analysis properly, if you have done your impact control matrix or cause and effect matrix properly, because 150 you narrowed to 20, you remember? Sorry, 145 you narrowed to 20. If you have done everything properly, your regression equation will be of the best quality. And the quality of the regression equation can be understood using a tool R square. Using a tool R square, which is also known as coefficient of determination. There is a formula using which we can calculate. If that R square comes closer to 100%, it means you have done a wonderful job in your project. If it comes closer to 100%, even if it comes above 80%, 90%, you should be happy about your contribution. You have done a wonderful work in that project. You have a thorough understanding of your process, and all that will happen. But in order to generate the correct value of R square, you have to again reconduct your hypothesis testing. Your study must be conducted. But now, with a slight upgradation in your experimentation. Earlier, I suggested you to study the factors one by one. Yes or no? X1 you study, then X2 you study, then X3 you study. You have studied all X1, X2, X3 separately. Now what you have to do is, you have to study X1, X2, X3 simultaneously. If you study simultaneously, you get your data in a slightly different format. You will have one column for x1. Remember an Excel sheet, right? One column, all the values of x1 will appear. In the next column, all the values of x2 will appear. In the third column, the values of x3 will appear. But x1, x2, x3, you have to record simultaneously. Do you understand the difference? But for x1, x2, x3, each set of x1, x2, x3, you will get only one y value. You will get only one y value, isn't it? So how many columns of data you have now? 4 columns. Why 4 columns? One is for output variable, 3 for the input variable. Why 3? Because these 3 are believed to be the root causes. So 3 columns for the root cause, 1 for the output variable. Now your experimentation is known as designed experiment. Tomorrow we are going to talk about it. Tomorrow whole day morning, I'll be talking to you about designed experiment. Once the designed experiment is connected, data is generated. Now you go for a regression equation. Look for the R square value. If the R square value is closer to 100%, you have done your best. You are now fully eligible to move on to the improve phase. What is that? Improve phase, where you actually think in terms of solution. If you have done your analysis very well, improve and control becomes a mere formality, right? It's a kind of brainstorming. It's a kind of change management. It's a kind of studying the situation and then coming up with, yeah, what do you call, an implementable solution. That is improve. Okay. And once the solution is implemented, solution should also be validated. Am I right? Solution should also see in define phase, measure phase. I told you, you validate your problem. In analyze phase, I told you, you have to validate your root cause. Now you have to validate your solution. How? Already the baseline is available. Yes or no? Now, after implementation of the solution, can you calculate the same baseline again? Same first pass yield, same CPCPK, same hardness, same surface finish, same accuracy, same turnaround time, whatever. Customer satisfaction index, employee satisfaction index, whatever metric you calculated in the measure phase, you recalculate. Will there be a difference? There will be a difference. And now the point is whether the difference is because of your project or is it random. Whether the difference is because of your project or is it random. Now there are two options, two situations. So either you can now go for a two sample test. It can be a two sample t-test or it can be a two proportion test. Today afternoon, RK will teach you two proportion test. Already we have taught you two sample t-test. Hope all of you remember, right? Test of averages. Depending on your y variable, if your y variable is continuous, go for the two sample t-test. If your y variable is discrete or attribute, then you need to go for two proportion test. If the test also gives a lower p-value, it confirms your solution is validated. It confirms your solution is validated. And finally, go to the control phase. Create a control plan and make sure your Y is stable. Y is statistically under control. You remember statistical control I told you in the define phase. Same statistical control should continue to happen for your Y variable even after the implementation of the solution. What are you supposed to do to sustain the statistical control in your Y? This is known as control plan. But now what is different? The control limits will be completely different now. You understand? Earlier, there was a control limit. You might have had a wider control limit. But now you will have a new control limit. The control limit is now narrower. Earlier, you had a center line in your control chart. Center line in your control chart. That center line earlier was away from the target. Let us say the compressive strength. I wanted a compressive strength of 200 Newton per mm square. But unfortunately, my process produced a compressive strength of 160 Newton per mm square only. Can you see your baseline away from the target? Yes or no? That will appear in your X bar chart. In your X bar chart, what is the center line? X double bar, isn't it? That X double bar is now 160. That X double bar is 160. But what is required is your X double bar should be equal to 200. After the solution, you will see your X double bar moving to 200. Earlier, the control limits were wider, but now the control limits have become narrower. You have to maintain this condition forever. What needs to be done for that? You demonstrated solution. Now all that your people should do is should sustain the solution. For that, you give them some guidelines. That becomes what? Control plan. This is what you all have learned in the first 4 days of the training program. Am I right? Define, measure, analyze, improve, control. Simply apply this logical proceedings in all project. Don't worry whether it's a manufacturing related project or a service related project. For manufacturing project also, there should be a metric. For service related project also, there should be a metric. In our training program also, if I want to do a Six Sigma project, I can do a project to ensure all our customers are highly satisfied. Then I will use a metric which can talk about your level of satisfaction. Isn't it? The rating you are giving, customer satisfaction index. I will create a formula to calculate the customer satisfaction index. Isn't it? Customer satisfaction index. We will create a formula and I will use the formula throughout my project. The formula should give due consideration to all the, all the bias that can happen. I must consciously control the bias. Am I right? Let us say if some participant know they were absent every alternate day, should I calculate their rating also? Or should I exclude?
Exclude.
I can exclude. He is an outlier, isn't it? So you should consciously control all the errors that can populate in your data so that your decisions cannot go wrong. Throughout your project, you should be conscious about the bias that can populate, and then control and use only data which are credible enough. So this is what is actually a DMAC project. Hope it has, helped you to recall your all the learnings and think in line with the systematic problem solving. Is my understanding correct?
Yes, sir.
Yes.
Yes, sir. Yes.
Yes, sir.
This 45 minutes, is it helpful
Yes,
to
sir.
recall your entire learning so far?
Sure, sir.
Very
Yeah.
helpful.
Yes, sir. Very helpful, sir.
Yes, sir.
Okay, so give me a
Very
thumbs
good.
up.
Very good.
We'll move on to new topics. Where is the thumbs up here in the chat box? React. Done. Thank you. Thank you very much. So we can now move on to the new tools, learning some new tools, right?